Okay, the final video for section 1-2 in your trigonometry book covers similar triangles. This is again an idea that you should have learned in geometry class, and if you had me for geometry, you did learn it. Don't tell me you didn't, because I know better. Okay, but we're going to review it. Similar triangles are the same shape, okay, which means that we have congruent angles. But they're not necessarily the same size. Okay, so the angles are equal, side lengths are not. It's not really a good way to phrase that. We should say angle pairs are equal. No, let's just not write that at all. Okay, the corresponding angle pairs are congruent, meaning equal. And the corresponding side lengths, while they're not equal, they are proportional, meaning they can be written as a proportion. So here we have a pair of similar triangles, ABC and DEF. Notice that we have the similar symbol, indicating that those two triangles are the same shape, but not necessarily the same size. Now what that tells us is that angles A and D are congruent, because they both come first in the name. Angle B is congruent to angle E, because they both come second in the name. And angle C is congruent to angle F, because they both come last in the name. Okay, that's what we know. Okay, because of this naming scheme, we can say angle A is congruent to angle D. They both come first. Angle B is congruent to angle E. They both come second in the name. Angle C is congruent to angle F. They both come third in the name. Finally, the other thing that we know is that we can write out a proportion comparing side length AB to side length DE. Notice how those are both in the same place. AB and DE are those vertical sides in your triangle pair. See how they correspond to each other? That fraction has to be equal to BC when it is compared to its pair, EF. And that has to be equal to AC when it is compared to DF. All three of those fractions must be equal. They must form a proportion. They must be proportional. So we're going to look at a couple of examples, one that makes us use the angle property there and one that makes us use the side length property, so we can remember what we're doing. So here we have a pair of congruent triangles. ABC is congruent to NMP. Okay, and we can see that they're organized that way. See how the A and the N are both marked as being 45 degrees? And C and P are both obviously obtuse. So we would start off by saying, okay, we should write a similarity statement. So let's start with triangle ABC is similar, and then we have to make sure we name the second triangle the same way. So since A and N are congruent, N has to come first. Since B and M relate to each other, M would come second, and C and P, so P would come third. Now what this tells us, again, is that, and we need to use the right colors here, so let's see. Angle A and angle N are equal. See how they're both 45 degrees? Angle B and angle M are equal. So that angle and angle M are equal. That's one of the things we're asked to find. Okay? The measure of angle B. Since the measure of angle M is equal to the measure of angle B, the measure of angle B has to be 31 degrees. And then finally, angle C and P have to be the same measurement. So again, we're asked to find the measure of angle C. Well, if the measure of angle P is equal to the measure of angle C, then the measure of angle C is 104 degrees. Problem done. Okay, similarly, here we have triangle ABC is similar to triangle DFE. Okay, so we have triangle ABC is similar to triangle DFE. That's given in the directions. So let's write out a similarity statement. ABC is similar to triangle DFE. Now, what that means is that side AB is to side DF, as side BC is to side FE, as side AC is to side DE. They are proportional. I know what you're thinking. Mr. Wills, when we did proportions, we never had 3 fractions. You're right. But we can use any 2 of those. We're never going to use all 3 at once. We're going to use 2 of them at a time. So let's plug in what we know. AB is length 24. So we have 24 is to DF as BC is 32. FE is 16. AC is 16. And DE is 8. Now you notice that we actually have 2 of those completed fractions. 32 over 16 and 16 over 8. Those fractions are equal. They should be. If you plug everything in right and you have 2 fractions, they've got to be equal fractions. So what we do is we ignore one of them. Okay, we're going to ignore this middle one because the numbers are bigger. Doesn't matter which one you ignore though. You're going to get the same answer either way. So that leaves us with 24 is to DF as 16 is to 8. How do you solve this problem? Well, you're supposed to cross multiply. Okay, so when we cross multiply, we get 16 DF equals 24 times 8, which is 192. And then we're going to solve that by dividing each side by 16, which gives us the side length DF is 12 units. That is, by the way, the only unknown side in triangle DFE. It's 12 units. And that answers the problem. That does it for section 2 in your trig book.